Hello and welcome to Technically Explained. In this video, we are going to solve some numerical problems of operational amplifier. So this is problem number 1 where we need to find the V0, the output voltage. The input voltage is given and we have input applied to the inverting side, to the inverting input. Now, we are going to have two cases for this. Case number 1 is when the input is DC voltage. This is your case number 1. Now when the input is DC voltage, this capacitor is going to be open circuit. So I can simply remove this capacitor for DC voltage. I am going to remove this capacitor. Now if you can have a look in the feedback, we have 2 kilo ohm and 3 kilo ohm resistor in series. So I can write this that in this case RF will be equal to 2 kilo ohm plus 3 kilo ohm because both are in series. RF is 5 kilo ohm in this case. Now because this is an inverting op amp, so the gain is minus RF divided by R1, which means that V0 is equal to minus RF divided by R1, which is the gain, multiplied by the input voltage. So V0 is equal to RF is your 5 kilo ohm has been found out minus 5 kilo ohm. R1 is your 1 kilo ohm multiplied by Vi, which is 2 volt. So when you solve this, you are going to get V0 is equal to minus 10 volt. Now this was for the DC case. For the AC case, when the input voltage is alternating current, this capacitor is going to, the capacitor that was originally over here, let me redraw that. Fine. And we have a ground over here. So this capacitor is going to act as a short circuit for AC. So I can replace this capacitor by a short circuit. So let me go on and replace this capacitor by a short circuit, and then that is connected to the ground. Now if we use the concept of virtual short, because positive terminal is connected to ground, the negative terminal will also be connected to the ground, which means that we have a ground over here as well, because this is the concept of the virtual short or virtual ground in this case. Now this is connected to the ground, these two are at same potential, so I can simply connect these two together by a line, which means that this 2 kilo ohm resistor has been shorted out. So I can simply remove this 2 kilo ohm resistor because current will not flow over here. Current flows in the least resistance path. I can remove this like this. So this is nothing but an inverting op amp. I can redraw this like this. I can just say that let me draw it in a better manner like this. So this is again your, for the AC case, this is your inverting op amp where Vi is your minus 2 volt. So again V0 is equal to minus RF divided by R1 into Vi, which is 2 volt. So V0 is equal to, now this RF is your 3 kilo ohm. I can simply put values minus 3 kilo ohm divided by 1 kilo ohm multiplied by the Vi, which is 2 volt. So this comes out to be minus 6 volt. So this is your answer for both the cases, for the DC case as well as for the AC case. Okay, let us move to the problem number 2. Here we need to find the R1. Now if you look at the problem number 2, let me check if the recording is on. It's on. So if you look at it, the problem number 2, this is basically an inverting op amp because positive is grounded, voltage is applied, the input voltage is applied at the negative terminal. So the gain is given, if you see over here, the gain is given, it says the voltage gain is minus 5000 and we need to find the Ri. Now we know that the gain of inverting op amp V0 by Vi is equal to minus Rf divided by R1. Now this gain is given, which is minus 5000. Minus 5000 is equal to minus Rf. Rf is also given, which is 10 kilo ohm, and Ri is unknown, divided by the Ri. Minus and minus will be cancelled out, so we have Ri is equal to 10 kilo ohm divided by 5000, which comes out to be 2 ohm. So in this case, Ri is equal to 2 ohm for the voltage gain of minus 5000. It was a very easy question. Let us move to the next problem, and that is problem number 3. Now in problem number 3, if you can have a look, we have a summing amplifier. This is your RF, this is R1 and R2, this is V1 and V2, and this is your output. Now we have R2 known. Now if you remember the equation for the summing amplifier, it was V0 is equal to minus RF divided by R1 V1. Okay, let me take the negative out full, plus RF divided by R2 V2. Fine. Now in this case we have R2 unknown, the rest are given. R1 is given, V1 is given, V2 is given, and V0 is also given. V0 is your minus 7 volt. This is minus 7 volt is equal to minus RF, which is 10 kilo ohm, divided by R1, which is 2 kilo ohm. This is your R1. V1, which is 3 volt. This is your 3 volt, plus RF again, which is 10 kilo ohm. R2 is known, so I am going to write R2 as it is. Multiply by the V2, which is minus 2 volt. Fine. Okay. This minus and this minus is going to cancel out, so we are going to have 7 is equal to, okay, 10k divided by 2k is 5, and 5 3s are is 15. So we are going to have 15 volt over here. 15 plus, okay, 10 2s are is minus 20. So this is minus 20 kilo ohm divided by R2. Now let me shift 15 to this side. So this will be minus 15. So we are going to have 7 minus 15 is equal to minus 20 kilo ohm divided by R2, which implies that we have minus 8 is equal to minus 20 kilo ohm divided by the R2. Let me remove minus from both sides, which means that R2 is equal to 20 kilo ohm divided by 8, which comes out to be 2.5 kilo ohm. R2 is equal to 2.5 kilo ohm, and then you can verify this if you want. Simply put R2 over here, you are going to get the output of minus 7 volt. Put all those V1, V2, R1, R2, and you are going to get V0 is equal to minus 7 volts. If you want to verify, you can always verify. Okay, then we have the problem number 4. In problem number 4, we are given a circuit, and this circuit is an differentiator, and we are also given Vi, and that Vi is given as e power, is given as that Vi of t is e power minus 2000 t volt. Fine. Now we know the output of this circuit. The output of this circuit is, let me write solution over here. Output is V0 of t is equal to minus RC, derivative of the input circuit. So just put values. Your R is given, which is minus 2000, C is 0.25, micro is 10 raised to power minus 6, we have microfarad, so 10 raised to power minus 6, and then we have the derivative of the input signal. So this is basically d by dt of the Vi of t, which is e power minus 2000 t. So this we are going to have minus into 2000 0.25 multiplied by 10 raised to power minus 6, and then derivative of this thing. So the derivative of this thing is minus 2000, again e power minus 2000 t. Fine. Now this is 10 raised to power minus 6. We have 3 zeros over here and 3 zeros over here. So this 10 raised to power minus 6 will be cancelled with 3 zeros and 3 zeros. And then minus into minus is again your plus sign. Fine, minus into minus is plus, so we are going to have plus over here, and then 2 2s are is 4, 4 multiplied by 0.25 is 1. So again we are going to have at the output e power minus 2000 t. So this is your V0 of t. That's what we intended to find out, and we have found out. Now let us move to the next problem, where we are asked to find the V0, again the output voltage. So now to find the output voltage, if you look here, this is Okay, I have a mistake over here. This is not connected over here. This needs to be connected to the negative terminal. This is connected to the negative terminal and not the positive terminal. Okay, now we need to find the V naught. First of all, let me mark VO1 over here, because I know that this is your non-inverting op-amp and I know the gain of the non-inverting op-amp. What I'm going to do is that I'm going to find the VO1 and then I'm going to do the further simplification. So first of all, what VO1 is equal to, I have named this output as VO1 and I know that this is your non-inverting op-amp because input is applied to the non-inverting terminal. The feedback will always be a negative feedback in case of op-amps. So now this output is equal to, we know that 1 plus RF divided by R1 into the input voltage, because this 1 plus RF divided by R1 is the gain of the non-inverting op-amp. And this RF, this is your feedback resistor 4 kilo ohm and this is your input resistor 2 kilo ohm. So we are going to have 1 plus 4 kilo ohm divided by the 2 kilo ohm into the V1, which is 2 volt. And this VO1 comes out to be, because 4 divided by 2 is 2, so 1 plus 2 is 3, 3 multiplied by 2 is 6 volt. So we have VO1 is equal to 6 volt. So now that is clear that here I have the voltage of 6 volt. Fine, we have simplified one portion of the circuit. Now for the other portion of the circuit, you look over here, we have 1 volt applied to the positive terminal. Again, using the concept of virtual short, we are going to have 1 volt apply over here as well at this node. Now because the input impedance of op-amp is very high, so no current flows over here, zero current flows over here. So whatever the current is flowing over here, let us suppose I call it I1. Same current is going to flow over here. Let us suppose I call it I2. Why? Because the current flowing into the op-amp is 0. So we are going to apply KCL at this node, at this 1 volt, and we are going to say that I1 is equal to I2. Why? Because no current flows into the op-amp. We have used the concept of virtual short to know that this node is your 1 volt. So now what is I1? I1 is now your VO1 minus this volt node, VO1 minus this node, which is 1 volt, divided by 4 kilo. And we have already found the VO1, which is your 6 volt. So I'm going to say that I1 is equal to 6 volt minus 1 volt divided by 4 kilo. And this comes out to be 1.25 milliampere. So we have found the I1, which is 1.25 milliampere. Now because I1 is equal to I2, I1 is equal to I2, so I2 is also 1.25 milliampere. Fine. Now what is I2? Let me say this here, that I2, let me draw a line for you so that you do not confuse. I2 is your 1 volt minus the V naught, 1 volt minus the V naught divided by 8 kilo ohm. And this is 1.25 milliampere. I2 is your 1.25 milliampere. So 1 minus V naught divided by 8 kilo ohm. Now 1.25 multiplied by 8 kilo ohm is 10 volt. Fine. So we have 10 volt is equal to 1 minus V naught, which means that V naught is equal to minus 9 volts. This is your answer of this question, that V naught is equal to minus 9 volts. So let us move to the next problem. Okay, your next problem is your cascaded problem. Now you have input given, you need to find the output voltage V naught. So now how to solve this problem? That take one op-amp at a time. Let us say that the gain of this op-amp is A1, gain of this op-amp is A2, and gain of this op-amp is A3. Now if you can see over here, this op-amp is your non-inverting op-amp because the input voltage is applied to the positive side, to the non-inverting side. So this is your non-inverting op-amp, and if you can see over here, this is your inverting op-amp because whatever the voltage is, that is applied to the negative side, and again this is your inverting op-amp because whatever the voltage is applied to the negative side. So A1 is your non-inverting op-amp, and we know the gain of non-inverting op-amp. So I can say that because these are cascaded, so I can say that the overall gain will be the multiplication of these three. Now this A1, what is this A1? First of all, let me find the A1. A1 is equal to, because this is non-inverting, so gain A1 is 1 plus RF divided by R1, which is 1 plus 470 kilo ohm divided by 470 kilo ohm divided by 4.3 kilo ohm. Right? So when we simplify this, we get 110.3. So this is 110.3. A1 has been found out. Now A2 is again minus RF divided by R1. Why? Because this is inverting op amp. So we have 470 kilo ohm divided by the 33 kilo ohm, which comes out to be minus 14.2. And same is the case for A3, because this is also inverting op amp and we have same feedback resistor and input resistor, so A3 will also be minus 14.2. So now the overall gain, because the overall gain is the multiplication of the three, so the overall gain is A1, which is 110.3, multiplied by this A2, which is minus 14.2, multiplied by this A3, which is again minus 14.2. This comes out to be 22.2 multiplied by 10 raised to power 3. So this is the overall gain of this circuit. This circuit is overall gain of 22.2 multiplied by 10 raised to power 3. Now we need to find the output voltage, and the input voltage is given, which is 80 microvolts. So output voltage is gain multiplied by the input voltage. Gain is this thing, 22.2 multiplied by 10 raised to power 3. And the input voltage is given to you, which is 80 microvolts. So you multiply these two and you are going to get the output voltage, which comes out to be 1.78 volts. This is your V0, which comes out to be 1.78 volt. Okay, let us do one another problem. This is your circuit for the subtractor. So to solve this circuit, I am going to use the superposition theorem. I am going to say that V0 is equal to VO1 plus VO2. So in first stage, what I am going to do is that I am going to say that V1 is equal to 0. So first of all, let me find the VO2. And for VO2, I am going to say V1 is equal to 0. Fine. Because superposition says that you shorted out or you ground one of the source, or you remove one of the source and find the effect of the other source, and then you remove that source and find the effect of the source that was initially removed. So, and then the overall effect is added. So for the VO2, I am going to say that V1 is equal to 0. And when this V1 is equal to 0, this whole portion will be grounded, because we are going to have ground over here, so this will be shorted, and we are going to have ground over here. So if I simply redraw this circuit, I am going to have this whole portion is going to be grounded. So positive terminal is going to be grounded, and then I am going to have an inverting op amp. Find, if I want to draw this, I can simply draw it again. We are going to have a 100 kilo ohm resistor, negative, positive is going to be grounded now, and this will be your V2, and then we are going to have 100 kilo ohm, also the 100 kilo ohm, 100 kilo ohm. This is your VO2. Why? Because when I remove V1, so this will be grounded. When this will be grounded, this whole thing is going to be grounded. So in that case, we are going to have an inverting op amp. And the gain of the inverting op amp is VO2 is equal to minus RF divided by R1 into the input voltage, which in this case is V2. Now RF, and this is also 100 kilo ohm. Fine, this is 100 and this is 100. So in this case, both are equal. So I'm going to have minus 100 kilo ohm divided by 100 kilo ohm into V2, which means that VO2 is equal to minus V2. This is my equation number 1. Fine, so we have found the VO2. Now let us find the VO1. We are going to find the VO1. For VO1 we are going to say V2 is equal to 0 volt because we are using the superposition theorem. So what we are going to say that let me redraw this circuit again. So, okay, I have redrawn the circuit and I have make V2 is equal to 0. In this circuit I have make V2 is equal to 0 and I have redrawn this whole circuit. So we have a circuit like this now. Now if we look at this point, let me name it as V plus. This V plus can be found out using the voltage divider rule. And that is using the voltage divider rule, we are going to have 20 kilo ohm divided by 20 kilo ohm plus 20 kilo ohm into the V1, which comes out to be V plus is equal to 1 by 2 V1. This is your equation A. Now when this is 1 by 2 V1, this node over here is also going to be 1 by 2 V1 because we have the concept of virtual short. So V plus and V minus will be equal. Now what is V minus over here? You can also find the V minus using the voltage divider rule. And again that will be 100 kilo ohm divided by 100 kilo ohm plus 100 kilo ohm into the V0, which in this case is VO1, which implies that V minus is equal to 1 by 2 VO1. Now V plus and V minus are equal, which means that we have 1 by 2 V1, V plus is equal to V minus equal to 1 by 2 VO1, which means that V1 is equal to or VO1 is equal to V1. Fine. So we have also found the VO1 and we have also found the VO2. VO2 was minus V2, VO1 was V1. Now let us put it over here. This is your V0. Then we are going to have VO1 is equal to V1, VO2 is equal to minus V2. So your V0 is equal to V1 minus V2. This is your answer because this circuit is a subtractor. Thank you. Please subscribe to the channel.